questions 5 through 7 on the 2014 grade 12 Euclid math contest. A chemist has 3 bottles, each containing a mixture of acid and water. Bottle A contains 40 grams, of which 10% is acid. Bottle B contains 50 grams, of which 20% is acid. And bottle C contains 50 grams, of which 30% is acid. She uses some of the mixture from each of the bottles to create a mixture with a mass of 60 grams, of which 25% is acid. Then she mixes the remaining contents of the bottles to create a new mixture. What percentage of the new mixture is acid? Well, we've got a situation where A, B, and C have 40 grams, 50 grams, and 50 grams. And then the percent of acid for each of these is 10, 20, and 30. And the number of grams of acid is, well, you just multiply 40 times 10%, so that's going to be 4. 50 times 20%, so that's 10. And 50 times 30%, which is 15. So now we want a situation where we want a mixture that has the following numbers: 60 grams, of which 25% is acid. So 25% of 60 grams is 15. So 15 grams of acid. All right. So what we can do is we can just kind of fiddle around with this. Here, if you add up these, this basically is 29 grams, right, of acid. Now 15 grams has gone into this mixture of this 29. So that means 14 grams, which is 29 minus 15, is what's remaining in these bottles, 14 grams of acid. And then the total was 40 plus 50 plus 50, which is 140, right? 140 grams. And of that, 60 grams was taken out. So what's remaining in terms of the total is 140 minus 60, which is 80. 80 grams total remaining. So basically this is the ratio now of what's remaining. The remaining contents are all mixed together, and they want you to figure out the percentage of the acid. Well, it's 14 over 80. And if you do that, it's 17.5%. And that's pretty much all there is to that one. Suppose that x and y are real numbers and that 3x plus 4y is 10. Determine the minimum possible value of x squared plus 16y squared. All right, so 3x plus 4y is equal to 10. Isolating for x, we get 10 minus 4y divided by 3. And then we can substitute into this equation that we're trying to minimize, and most likely we're going to have to complete the square. Anytime I see minimum, maximum, I think of completing the square. But first, let's make our substitution. 10 minus 4y over 3 plus 16y squared. So this is going to be 100 minus 80y plus 16y squared, all over 9, because we got to square that. And then let's put this all over one fraction. So if I'm going to put that over 9, I'm going to have to multiply 16 by 9 to make it 144. Okay, let's combine these now. So that's going to be 160y squared minus 80y plus 100 over 9. I think I can factor out a 20 here. And when I do, I get 20 over 9. And that leaves me with 8y squared minus 4y plus 5. Now we will complete the square. 20 over 9, I factor out an 8. And when I do, I get y squared minus 4 over 8y plus 5 over 8. Right? And then now, if you remember how to complete the square, you take half of this and square it. So that's actually just a half. So half of a half is a quarter. A quarter squared is 1 over 16. So this is y squared minus a half y plus 1 over 16. Then you have to immediately subtract it. And don't forget about that 5 over 8. Okay, let's bring this up over here. So we got 20 over 9. And then this is 8. And then these three now factor. So it becomes y minus a quarter all squared. And then now we have to add those and multiply by the 8. So when you kick it out of the bracket, it becomes minus 8 over 16. And then plus 40 over 8. Like that. Okay, doing pretty good here. And then we have to add this now, this fractional part. So a common denominator of 16, that'll be 80 minus 8. So 72. 72 over 16. Like that. So now it's in the form when y is equal to a quarter, this will be at its minimum. This part vanishes, it becomes 0, and all you're left with is just 20 over 9 times 72 over 16. And that is equal to just 10. So that is the minimum possible value of that expression right there. A bag contains 40 balls, each of which is black or gold. Fermat reaches into the bag and randomly removes 2 balls. Each ball in the bag is equally likely to be removed. If the probability that 2 gold balls are removed is 5 over 12, how many of the 40 balls are gold? Well, let's talk about this. We have, what are the colors? Black and gold, right? Let's say there are X black balls or gold balls, and since there's 40 of them in total, 40 minus X are black. So if we want to choose one gold ball, the probability is X out of 40. If we want to choose the second ball also to be gold, well, now there's only X minus 1 gold balls remaining, and there's only 39 balls remaining in total. So this is basically how you calculate the probability. And they're telling you that probability is 5 over 12. That's it. This is the equation we have to solve. So cross multiply and you get 12x times x minus 1. And on this side we get some big long number here, 5 times 40 times 39. Let's put everything on one side. Let's divide through by 12. I think that should be able to make our life a little easier. X squared minus x, and when you divide through by 12 on this side, you get 650, I believe. Okay, now let's put it all on one side. X squared minus x minus 650 is 0. And I think this factors, let's attempt it, x 25, 26, positive, negative. Yeah, great. So that means x is 26. There you go. That answers the question, how many of the 40 balls are gold? The geometric sequence with n terms, t1, t2, all the way to tn, has t1 times tn equal to 3. Also, the product of all n terms equals 59049. That is t1 times t2 all the way up until tn. Determine the value of n. All right, so in any geometric sequence, it's of the form a, ar squared, ar cubed, and so on, right? All the way dot, 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 until you get the very last one, which is ar n minus 1. So this is our t1, this is our t2, t3, t4, and at the very end it'd be tn, correct? The first thing that they tell me, hopefully a very helpful piece of information, is right here, that t1 times tn is equal to 3. Okay, at this point doesn't seem like it helps us much, but let's try and see what happens when we sub these guys in. T1 is really a, and Tn is a times Rn minus 1, and that is equal to 3. So what that means is this is a squared times r times n minus 1, and that equals 3. Okay? All right. Let's see what happens later on. Now, let's look at this one, that when you multiply them all together, it equals 59,049. So T1 times T2 dot 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 until you multiply it by Tn. So substituting our a's, we got ar squared, and so on, right? All the way until you get to arn minus 1, and that is 59049. Okay, so how many a's do we have? Well, there's going to be n a's. So it becomes a to the power of n. Now, how many r's do we have? Well, it's r to the power of 1, r to the power of 2, r to the power of 3, all the way up until n minus 1. And some of you will remember that if you have consecutive numbers like that, there's a formula. So, for example, if you have 1 plus 2 plus 3 dot 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 all the way until n, it's n times n plus 1 over 2. Very famous. By grade 12, you should definitely know that. But this time, we're not adding until n, we're adding until n minus 1. So r's becomes n minus 1 times n minus 1 plus 1 over 2, our sum. So it really is r to the power of n minus 1 times n over 2, like that. Okay, so where do we go from here? So far, it seems like that is helping, but we have to obviously use this piece of information. So we have to get it into that form. How do we get into that form? Well, I'm going to have to square it, because this is a squared, and I don't have a squared, I have a to the power of n. So I'm going to square this. When I square it, I get a to the 2n, and then r to the n minus 1 times n. And this becomes just 59049 to the power of 2. Okay, so at this point, I can factor out an n. So this becomes a squared r n minus 1 all to the power of n. So using basic exponent rules, we can do that, no problem. And this is some big long number. I'll just leave it like this. Great. Now we can make this substitution. This right here is equal to 3. So this whole thing just becomes 3 to the power of n is equal to 59049 to the power of 2. At this point, you can use logs. It'll work out pretty nicely with logs. Log of 3 to the n is equal to the log of 59049 squared. Using log rules, that becomes n log 3 is equal to the log of this. And now all we have to do is just isolate for n. N would be the log of this big long number over the log of 3. And when you get out your calculator and you calculate that, you will get n equal to 20. And I encourage you to go back and verify if this actually does work. It's not required, but, just to make sure. If x minus 2013 times y minus 2014 over x minus 2013 squared plus y minus 2014 squared equals negative a half, what is the value of x plus y? All right, so make some substitutions here. It makes it a little bit easier. X minus 2013 I will let equal a. Y minus 2014 I will let equal b. So that original expression, then if you substitute those, becomes a times b over a squared plus b squared. And that is equal to negative a half. Now cross multiply and you get 2ab is equal to minus a squared minus b squared. Put everything on one side and you get a squared plus 2ab plus b squared is equal to 0. This factors out very nicely, a plus b squared. is equal to 0. So that means a plus b is 0, and a is equal to negative b. Right, now let's make those substitutions. A is equal to negative b, so that means x minus 2013 is equal to negative y minus 2014. So x minus 2013 minus y plus 2014. Put the x and y on one side, x plus y. Put the numbers on one side, 2014 plus 2013. And therefore x plus y is equal to 4027. And that's what they wanted you to figure out, the value of x plus y. Determine all real numbers for which the log of x to the power of the log of x is equal to 10,000. All right, let's make some substitutions again. And I'm just going to write the log. Since it's all base 10, I'm not going to keep writing base 10. It's not necessary. When there's no base written, it's assumed it's base 10. So, I mean, when you make that basic substitution, this now becomes a log of a, and that equals 10,000. So at this point, where do we go from here? Well, take the log of both sides. Log of a, and this becomes the log of 10,000. But instead of writing 10,000, I'm going to write it as 10 to the power of 4. Now, basic log rules, you bring the log out front, log of a, right? This guy comes out front like this, and then we just have times the log of a. And this part, the 4 comes out front, and we have the log of 10. Well, this becomes the log of a squared is equal to 4, because the log of 10 is just 1. Take the square root of both sides, and when you do, you get the log of a is equal to plus or minus 2. So that means 10 to the power of 2 is a, or 10 to the power of negative 2 is a. So that means a is equal to either 100, or a is equal to 1 over 100, like that. Okay, but we don't want a, we want x. All right, no problem. Let's go back to our original substitution. The log of x is equal to a. First, let's do it for 100. That means 10 to the power of 100 is equal to x. That's one value. Now let's use a as 1 over 100. So that's really like that. So that means 10 to the power of 1 over 100 is equal to x. And there you go. X is either 10 to the power of 100 or 10 to the power of 1 over 100. And as always, you know, if you have time, although you don't need to, if you have time, it's always good to verify. Put these values of x back into here and see if it works out.